Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is reverse linked list. So you will be given head of a singly linked list. For example, this linked list will be given to you 1 2 3 4 5, and you have to return the reversed linked list, which is 5 4 3 2 1. Okay, let's have a look at the constraints before thinking of a solution. The number of nodes in the list can be from range 0 to 5000, and values of the node can be from -5000 to 5000. Okay, you have to there is a follow-up also that a linked list can be reversed either iteratively or recursively. Could you implement both? Okay, so we will be talking about iteratively here. I will urge you to try out to do it recursively. If you are not able to do that, I will provide you the code. So right now I will show you how to do it iteratively. Okay, so let's see how we can achieve that. So let's say this is the linked list given to you. Okay, and after this it is terminating and it is pointing to the null. Okay, so how we can reverse this whole linked list in a single pass and iteratively. So what we will be doing is we will be having 3 pointers basically. First will be your current pointer. Okay, let me name them here, current. So this pointer will help us to traverse the whole linked list from left to right direction. Initially your current will be starting from the very first node and it will be going till the very last node that is there. Okay, and your traversal of linked list with the help of current pointer will terminate as soon as your current reaches a null node. Okay, so then you will be running a loop while this current is not equal to null. Okay, and you will keep incrementing the values of current, shifting it to one node ahead. Okay, so you will also be having a previous variable. Okay, which will be initially pointing to a null location. Okay, why I am showing this null location here, because when we will be uh, reversing this linked list, so how it is gonna look, it will be looking like something like this: 3, then 2, and then comes 1, and then 1 will be pointing to null. Okay, that's why I am what I will be doing is I will be just changing the links. So effectively I will be doing this: instead of this link, 1 will be pointing here, and instead of this link, and then 2 will be pointing here, and this link will be broken, 3 will be made to point to 2, and yeah, then you will be simply returning this 3. Okay, so how we can do that programmatically, that is the question here. So what we'll be doing is, initially your previous will be pointed to null, then what you will do, you will change this link. Okay, once next pointer will be pointing to the previous node, or the node to which previous is pointing to. Currently previous is pointing to null, so what you will be doing is, firstly you will be storing whatever is the next value for the current pointer, so that once we have broken this link we will not be able to reach it. so that's why we need to store it somewhere. So we will be having another pointer next. It will be nothing but, okay, current dot next. It means this node. We will somehow get hold of reference of this node, and once we are having that, we will break this link off. Okay, so we will break this link, and how we can do that? We will simply change the next of current. Okay, it will be nothing but previous. So now this link is gone and it is made to point here. Okay, so now once we have achieved it, we will be moving our current one node ahead. Okay, so how we can do that? Before moving our current one node ahead, we have to do one more thing, which is moving our previous to the current node which current is pointing to. Because later down the line, you have to change this, break this link and make this link to point towards 1. So that's why your previous should be at 1 at that time. So that's why, here what you will be doing is, you will be changing your previous to current. Previous will be made to point to the node to which current is right now pointing to, or let's say having reference to. Okay, so your previous will be coming here. Okay, and then once you have done that, what you will do, you will move your current pointer ahead, which will be nothing but current will be shifted to this next value. Okay, so now the situation is like this: your current pointer is here and your previous pointer is here, and this is the link that is once next is pointing to, and currently we are on node 2. So we will do these steps for node 2. First of all, we will store the reference of node 3. We will be doing this here. Then what we will be doing is, we will be breaking this link off, or not this link, sorry, this link off, and we will make it to point in this direction. Okay, so once you have done that, like current dot next will be pointed to previous, then you will move your previous one position ahead. So right now you will be having something like this. 1 is right now pointing to null, and then 2 is right now pointing to 1, and after this line is executed, this link is already gone, and your current will be here. Okay, and your previous pointer will be here. Okay, and it is right now pointing to null. So you are having a situation like this. Okay, so then you will first of all store the next node to the current, which is null, by the way. Okay, so next will be having null, and then we will break this link off between 3 and null and change it to make it to point towards 2, which is we are doing in this particular line. Current dot next is made to have a reference of previous, which is 2, by the way. So previous was having value of 2, or reference of 2, you can say, and then yeah, this link is broken and a new link is formed, and your previous will be moved to this place on 3. So now previous will be on 3 after this line is being executed, and after the last line is being executed, your current will be pointing to next, which is null, by the way. Okay, So this loop will terminate as soon as your current reaches null. Okay, this condition will stop being true, and your current will be reaching to null, and you will be having a reversed linked list. And now the question arises, which of them, which of current and previous would be pointing to the new head? And it is 3. It is previous. Okay, as you can see, previous is right now at 3 when this whole thing terminated. Okay, so then you will be simply returning previous. Okay, so this is how how we will be doing it iteratively. Try to do it recursively. If you are not able to do so, I will be providing the code. And as far as time and space complexities are concerned, let's say linked list size was n. Okay, so the time complexity will be order of n, and space complexity wise it will be order of 1, since we are only playing with the links here. Okay, and order of n because we are doing a linear traversal, and only once we are doing it. So whether it's linear or not, that matters, but how many times you are doing it usually do not matter, as long as you are doing, I guess, in a constant number of times. So it's order of n anyways. Okay, and let's implement this approach. So I guess I have written the code also, but let's anyways type it. So let's define a function return reverse. Okay, this reverse function will be giving us the head of the reversed linked list. Okay, let's define a private function. It will be returning a list node. So head is of type list node, reverse list node, and then head. Okay, so first of all, you will be storing it in a variable current, which will be helping us to traverse this whole list, and we will be doing this operation till your current value do not reaches to null. And you will also be having another variable previous, which will initially be pointing to null, as we talked about in the slide. So initially previous was pointing to null. Okay, so now coming to this loop, you will be having, you have to somehow get hold of next node for current, which is next node. You can say, instead of next, I am taking next node, so current dot next. Then you will be breaking the previous link that is there, which is current dot next will be now made to point towards previous. Okay, and then you will be moving your previous pointer to the current. Okay, so that when you will be doing this whole thing again, this thing, your previous should be at the correct position. So previous will be equal to current, and then your current pointer, or let's say reference, should be moving one node ahead, which is next node, by the way. So the whole reason of using this current next node is being because once we have changed this link, we will be no longer having access to the next node for current. So that's why we are storing it prior to doing modifications with this link. Which link I am talking about? This link which was earlier present. Okay, so now once we have done this whole thing, current will be reaching null eventually, and what pointer will be at the head of the reverse linked list? That will be our previous pointer, as you can see here in this particular case or step. So you will be returning previous here. Okay, So I guess that should work. Let me have a quick look for any syntextual mistakes or typos. I guess everything looks fine. Yeah, I think it's fine. Okay, let's try to submit it for sample test cases. Yeah, it's working for sample test cases. Let's submit for final evaluation. Okay, yeah, it is getting accepted for all of the test cases that are there. So that is how you will be solving this particular question. If you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.